Hello guys. So one of my students was telling me that this was an interesting problem to explain because of the algebra behind it. So I hope this is useful as a review. And let's pay attention to the trigonometry as well as the algebra because the trigonometric principles are really quite important here. So they tell you that you have this little car that is driving along a road towards a mountain. Okay. And then the mountain has an unknown height. So let's say that this is your little mountain over here. And then what you don't know is what is the height of the mountain relative to the ground. Okay, this is your unknown h. And they also tell you that when the car is at a certain distance, the angle of elevation of this car towards the mountain has a value of 10 degrees. Remember, the angle of elevation is measured with the horizontal. Also, when the car is, well, 10 minutes later, at some point forward, closer to the mountain, then this angle of elevation is just going to be quite higher, 70 degrees. So, basically, the idea is you have to first consider that there are two distances here that you don't know. You have the distance from the car to the base of the mountain right behind the midpoint that we don't know. We can call it x. And then you have this other distance, which is the distance between the original position of the car and the final position of the car. Now that can be easily calculated. You know that the car is going at 60 kilometers per hour, which means that you have 60 kilometers in 60 minutes. 60 kilometers in 60 minutes means 1 kilometer every minute. And therefore, in 10 minutes, you have a distance of 10 kilometers between the two different positions of the car. Now, automatically, this means that what you get is a right triangle that is wide and has an adjacent leg of x plus 10 and an unknown height of h. And then you have a narrower triangle that has an adjacent leg of just x and the same unknown height of h. And so in those two, you know the angle. In the first case, your angle is 10 degrees. In the second case, your angle is 70 degrees. So what we are going to do is we're going to need the combination of the proper trigonometric ratio with these quantities, h and x plus 10, h and x. And you guessed it, because what you get is the opposite leg and the adjacent leg, the proper trigonometric ratio that we need to use is tangent of theta is equal to opposite divided by adjacent. So let's move on to a cleaner place and let's work on that. Your first triangle, which is wider, but it has the same height as the other one, has legs h and x plus 10, and their angle is 10 degrees. Therefore, your tangent is the tangent of 10 degrees, and it is equal to opposite h over x plus 10. Then your second triangle, which is narrower, but it has the same height, has a height of h, an adjacent leg of x, and the angle is 70 degrees. Therefore, your equation becomes tangent of 70 degrees is equal to h divided by x. So you guessed it, this is a system of two equations with two unknowns, and the unknown that we care about is the variable h. That's what you want to know. You don't really care about x, although you could find it. But what we want to know is h, and that requires quite a few steps in the algebra field. So you multiply times x plus 10, and you get x plus 10 times the tangent of 10 degrees is equal to h. On the other hand, you multiply times x, and you get x times the tangent of 70 degrees, and that's equal to h. Remember, you don't really want to solve now, because if you set the left-hand sides equal to each other, then you're going to find x. But you don't want to find x, you want to find h. So you want to solve this for x. So x plus 10 is equal to h divided by the tangent of 10 degrees. And x is equal to h divided by the tangent of 70 degrees. Also, by combining a little algebra here, x is equal to h over tangent of 10 degrees minus 10. And on the other hand, well, you already have it solved for x, so you can only copy this. The most important part of this whole thing is that you can now set the right-hand sides equal to each other, and so h over the tangent of 10 degrees minus 10 is equal to h over the tangent of 70 degrees. Now you want to solve this for h, but you have h on the two sides of the equation, so you are going to have to move things around a little bit. H divided by the tangent of 10 degrees minus h divided by the tangent of 70 degrees is equal to 10 kilometers. And because you have one h only, you can take common factor here. 1 over tangent of 10 degrees is what is left inside of the parentheses. On the other one, 1 over tangent of 70 degrees is equal to 10 kilometers. Now, this parenthesis, you can calculate that with a calculator. You don't even need to set parentheses or any special order in the calculator. Just write it in the order that you have it there, and you can write it with as many decimals as you want to 5 decimal places. That's 5.3731. And now this is a very straightforward thing. 10 kilometers divided by 5.3731. And the final result is that your height is equal to 1.88 kilometers. Or if you want to give it as a more conventional number, 1,880 meters. So that will be the answer. But before we leave, the most important thing to discuss is that what you're doing actually is that you are combining two equations that actually come from the idea of having two triangles. So the most important part is I want to set up the triangles. I want to be able to say this is made by a right triangle from the car at the beginning to the mountain, and from the car at the end to the mountain, and that's what we need to discuss in the problem. So this is a nice example of application of trigonometry. I hope you liked it, and I'll see you next time.